Hello everyone. Last class I showed how to find or how to draw ILD for reactions at A and B and the shear force Vx and bending moment Mx. Now we will see how it is influence lines are used. So influence lines are used to find out the value of function at a section for which the influence line is drawn for a given system of loading. Okay, this the system that may be a series of concentrated load or uniformly distributed load means you have to draw ILD for the system or series of loads. It may be a single point load, or it may be a 2-point load, or it may be a series of concentrated or point loads or uniformly distributed load. Uniformly distributed load, under this there are two categories. So smaller than the span and second one is larger than the span. So there are 5 conditions you have to study, means 5 uh, you have to study the problems under 5 different headings. The first one is concentrated loads, means single concentrated load. Next is two concentrated load or 2-point loads. Next is series of concentrated loads or series of point load. And uniformly distributed load, again 2 types, larger than the span and smaller than the span. So I will tell you how to find if the load is given. Last class what we have done, we have considered only one unit load. For that you have drawn ILD, correct? But now there are loads, means one vehicle is moving like that. So that time you have to consider that effect. That effect. Okay, so now let us consider if I'll show you the example of series of load, because same thing you have to apply for single load or 2-wheel load. Okay, now suppose there are series of loads, 4-wheel loads are there. Okay, here one load W1, this is W2, this is W3 and W4. They are at different distances. Suppose it may be at 1 meter distance, this is at 2 meter distance, this is 3 meter, this is 4 meter, like that. So total span is L. So section is here. Okay, this is a section which is at a distance of X from A. So this distance is now L minus X, because L minus X, L minus X. Now, how to draw a shear force diagram? First, I will tell you about this ILD for shear force. You know now what you have to do. You have to consider the section. First, you have to consider left portion. Then you have to consider right portion. Left portion means unit load is in between A and X. So then you have to find shear force at X. What is that? Shear force at X is minus RB. So minus RB means minus Y by L. Next, you have to find a different point. Suppose this is at A. So this is suppose at C. This is suppose X. This is D. This is E. This is F. So at various locations you have to find. So you will get that value. How you got in the last class, last problem, 0.5, 0, 1, like that. You will get these values depending on the distance. So what you have to do after that, you have to find total shear force, because there are 4 wheel loads. You have to find total shear force. How you can find total shear force is W1, whatever the load is given here, W1 into this F1, F1 dash. Means suppose it may be a 0.6 or this is 0.7, this is 0.3, like that. Whatever value you get, no, that should be multiplied by the given load. And for the shear force, you have to consider this diagram, ILD for shear force. Okay, if it is for bending moment, you have to consider ILD from the bending moment diagram. Now, first we'll see how to find shear force. So, W1 into F1, F1 dash plus W2 into this F2, F2 dash plus W3 into F3, F3 dash. Next, W4 in plus W4 into F4, F4 dash. Means this total shear force is the algebraic sum of all the loads multiplied by their corresponding ordinates. This is the way to find the total shear force. Similarly, you have to find the total bending moment also. Now, same method, you have to just refer bending moment diagram. Okay, here you get the values. How you get bending moment at X? Again, you have to consider left portion and right portion. Left portion means unit load is in between A and X. Here, you have to imagine. I have not shown here. Next, it is in between X and B. When it is between A and X, bending moment at X is RB into this L minus X. When it is in between X and B, that is RA into X. Then you find a different point. Suppose this is at A, Y is equal to 0. Then at C, what is Y? Whatever the distance, suppose if it is 2 meter, whatever you consider. So you get all these ordinate values. So total bending moment is this W1 into M1, M1 dash plus then W2 into M2, M2 dash plus W3 into M3, M3 dash plus W4 into M4, M4 dash. So it is the algebraic sum of all the loads multiplied by their respective ordinates. That gives the total bending moment. See here at the section, it is maximum. There is no loading, so you don't get any values here. Okay, and here also shear force at the section there is nothing, so you no need to multiply this. Where there is a load, that has to be multiplied by the corresponding ordinates. Okay, this is the way to find the total shear force, whether it is a single load or two loads or series of loads. Okay, next, this is one case. This is applicable for all the point loads. Okay, I already told single load, two wheel loads and series of loads. Next, we'll see how it is for uniformly distributed load, second category. Uniformly distributed load, what happens? This load, it is uniformly distributed from here to here, W per unit length. It is not like point load. Point load is at that point, but here it is varying point. So you have to draw the shear force and bending moment diagram. This is the common diagram, the basic diagram. How shear force at X, you will have two values. Here one value, here one value, and at A it is 0 and at B it is 0. Okay, so this is the diagram. At the section, two values. Next, for bending moment, how it is at A 0, at B 0, and at the section it has the maximum value. So this is the standard diagram. After that, you have to extend this where UDL starts and where it ends. So draw that line. Now, how to find total shear force in this case? What you have to do? You have to, again same thing, multiplied by W into this ordinate. What is this ordinate? This is nothing but area. Area of ILD covered by the load position with respect to this diagram. ILD for shear force. Okay, so total shear force, how you calculate? Total shear force is equal to this intensity W into area of ILD covered by load position with respect to ILD for shear force. That means W into area of ABCD. This is trapezoidal. So that area you have to consider. Similarly for bending moment, how you consider? Total bending moment is equal to W. That is W into the W per unit length into A dash, B dash, C dash, D dash. Area of ILD covered by the load position with respect to bending moment of ILD. That means W into A dash, B dash, C dash, D dash. You have to consider this area. That's it. So this is the way to find, to draw or to find total shear force and bending moment in the case of uniformly distributed load. It is same for both smaller than the span or larger than the span. The method is same, only so now I think you got that. How in the case of simply supported beam with the point load, if it is a single load or two wheel load or series of load, you have to just multiply by that load into ordinates. But load into ordinates. Same thing, bending moment also load into ordinates. But in the case of uniformly distributed load, you have to multiply it by area, load into area. That is the difference. If it is for shear force, you have to take it from shear force diagram. If it is for bending moment, you have to take it from bending moment diagram. Here also, if it is for shear force, take it from shear force diagram. If it is for bending moment, take it from bending moment diagram. Okay, this is these things we are going to do now. Next class onwards, I'll start with the problems. And one more important thing you should know, this is the note. You just make a note. Always you have to do like this. When the unit load is moving from left to right, means unit load is moving here to here. What happens? Suppose if it is a series of loads. Now series of loads are there. Unit load is moving from here to here. Which is the first load now? This is the first load, because this occupies the first place, this place. So now this is the leading load. Okay, so W3, W2, I have written in the other way. Here I have shown W1, W2, W3, W4, or you can show W4, W3, W2, W1. Anyhow, which it comes here, which occupies this position, that is the leading load. Here I have shown here, moving from left to right, this arrow mark. So three loads. So this is the leading load. This is the last load, trial load it is called as. Okay, next, if the unit load moving from right to left in the opposite way, means unit load is moving from here to here. Okay, then what happens? This place occupies the first position. This load occupies this position, that is the first position. So that time W1, W2, W3, this is the leading load. So okay, just see this, you have to be very clear regarding this. Left to right, this is the first position. This load is the leading load. If it is moving from right to left, this is the leading load. These two things you have to remember. Okay, just go through whatever I have done till now properly. Then we'll start the problem. Then only you will understand. Otherwise, it is very difficult. Okay, thank you.